Hey guys, I'm Heather Gorham. I'm a principal at Flying Fish Ventures, which is an early stage venture capital fund that's based in Seattle. I am based in San Francisco, and I am so excited to share with you this conversation that I had with Archit Sharma, one of the co-authors of the paper, Direct Preference Optimization, Your Language Model is Secretly a Reward Model. Now, alongside Archit, this paper was co-authored by Rafael Rafailov, Eric Mitchell, Stefano Ehrman, Christopher Manning, and Chelsea Finn, and was also awarded Outstanding Paper runner-up at NeurIPS 2023. The work in this paper does a lot to better democratize AI alignment, which is great from both a safety and a usability perspective, so I hope you enjoy this conversation. This is part of a broader series as I dive in with different AI researchers who are leading forward change in AI systems and architecture. Let me know if you think there are other AI researchers that I should talk to, and thank you so much for watching. With that, let's jump in. Well, cool. I'm glad to be able to talk. Maybe before we dive in, it would be good to start with how we got to where we're at today and the use of preference learning in order to control and kind of augment large language models.
The language model, like the way they're trained, is to train any text on the internet. So you want that to be usable from users. And what does being usable from users mean is that like they should satisfy what user expect the model to do. So that's where the preferences sort of come in. Now, why preferences? It's actually awfully hard to design, what reward model or what reward should I optimize for? What objective I should optimize for? Designing that is actually very hard. So something that really helped here was the fact that, if we just ask human users what do they prefer as an answer, that implicitly tells us what reward functions humans are looking for. And we can implicitly optimize for that kind of an objective. And this is really nice because, humans are actually really good at telling, oh, this answer is better than this one. Maybe it's hard for them to write down answers. That's not very scalable in terms of collection, but it is much easier for them to label, this answer is better than this answer.
That process, what you just described, using the preferences to tweak and augment the reward functions, gave us RLHF, reinforcement learning through human feedback, which I think is a pretty common thing kind of in industry. Can you talk about how the current state of RLHF in its use in language models?
Sure, yeah. So roughly for a few years, the following recipe was used to get very usable and steerable language models. You start with some base model. You collect a large set of instructions or questions that a user might ask, and then you let the model generate some possible answers for those questions. Then you ask users, which answer do you prefer for this question? And the users will either give some form of ranking or some kind of preference over that data set. And then you take all that data and you fit some reward model or some kind of some model which basically tells you that this answer is better than this one. So it gives you a number for this answer is really good, let me give you a +1, or some answer is really bad, let me give you a -1. So you get some kind of a model which scores these answers, and then you use the technique called reinforcement learning to take this reward model and optimize it so that you produce the answers that humans would typically like. There's a two-stage process this is happening, which is right now is you first fit a score, which tells you what the score is, and then you optimize that score to produce better answers. And the end product is you get a model which is more aligned with what the users want typically. So when you ask it a question, it will give you the answer that you're expecting and not just anything what the internet might want to say.
Right, how we're getting better quality models and responses, so the user experience gets better when there's that learning is involved.
Absolutely, yes.
This is kind of the predecessor framework to what you then went out to work on, which is direct preference optimization.
Yes.
So why was this not the right way to do things? Why is this really not a reinforcement learning problem?
So I will say it's still a reinforcement learning problem, strictly speaking, because at the end of the day, you are trying to satisfy user preferences, which is kind of this black box thing. You cannot write down the handcrafted rules for, a user typically likes an answer which has big words or something like that. Those kinds of handcrafted rules are really hard to. So there is a reinforcement learning element to it. The reason why reinforcement learning from human feedback is complicated is that first there's two stages. So any process which involves many stages typically has more points of failure, and that becomes really hard to tune for practitioners. And specifically, reinforcement learning, the algorithms which like optimize these scores can actually be very, very computationally unstable or expensive to do. So as a reference, like I mean, the techniques that were related to RLHF were pretty much restricted to like really top places like OpenAI or Google,
Right.
and really they were only able to do RLHF properly. Whereas like everybody like there were new open source models coming out, and you could instruction tune them to an extent, but you were not getting the same kind of usability that a lot of the closed source models had.
Yeah, a lot of what I was seeing, at least from startups, was some sort of retrieval augmented generation
Yes.
type RAG system
Yes.
to try and get to that little bit more fine tuned. Because yeah, to your point, the data sets for RLHF are vast and very expensive to use.
They're expensive to collect, and they are really computationally expensive to tune as well. So like if you start the process, if you start iterating on the algorithms, there's like hundreds of parameters you have to potentially tune just to like get something working. And then typically you have to run the algorithm many, many times on many, many GPUs, which are often not very accessible.
Right.
And it requires a lot of know-how just to like even get started on this. So these techniques are very behind the walls and not very accessible. And this is not just about accessibility. I think that's a really nice appeal of direct preference optimization. But simpler things just are more understandable for everybody. And that's where I think like the big appeal of direct preference optimization is.
Yeah, so let's maybe go into that a little bit and at a high level, the framework, and then we can kind of get into the nuts and bolts of it. What is DPO?
Awesome. Very excited for this part. So the essential idea of what makes DPO appealing is that it is solving the exact same problem RLHF is. So you're still, taking a set of questions, and you're taking the same set of preferences that you collect, and you get humans to label, oh, hey, like I like this answer more than this answer. So it's the exact same data sets that you use typically for RLHF. So you're not compromising on like any aspect that way. But what is the nice part is that like there's no two-stage process. All you're doing is you're taking your language model that you started off with, and you're optimizing it to like produce answers which are more similar to the answers that typically users prefer, and trying to avoid the answers which users typically do not like. And this is just a simple one-stage process, and there's very few hyperparameters, there's very few things that you have to tune in the algorithm, so it's very memory efficient, and it's very accessible to people. So there's no two stages, you're directly optimizing for the preference, which is why it's called direct preference optimization.
Yeah, the crux of this framework in your paper, you say, is the change of variable to define preference loss as a function of the policy directly.
Yeah.
Talk about why that's so important.
Absolutely, yeah. So this is like the nice appeal of DPO in some sense, is that like, okay, let me take a step back and like sort of talk about why this even happens. Reinforcement learning, like we said, like we want to maximize some kind of score. The score is typically like how much do humans like a certain answer. And we have this like funny term in there, which is, oh, I want to maximize a score that humans like, but I don't want to drift too far away from where my initial language model is. So you get this like optimization problem, which is the KL constrained reinforcement learning problem. Now it turns out that like, there is an optimal solution to this problem. Now, I won't go into the details about how this comes through and whatever, but the key idea is that there's actually a very close relationship between the reward function that you're learning and the optimal policy. Essentially, like every reward function induces some kind of, oh, this policy or this kind of a language model is optimal for this kind of a score. And you can sort of invert the relationship here as well as say, oh, every language model is optimal for some kind of a score function. And this kind of the key property that we exploit in direct preference optimization. And maybe this like gets to where we are at is that because I can write my score in terms of my language model itself. So the probabilities of my language model are no longer expressing just how likely a certain sentence is, but it's also expressing how likely a human is to like the sentence. So you're kind of like using the log probabilities to use both of those things. And that's where the key property DPO comes in, is that instead of just fitting a separate reward model, you express the reward model in terms of the language model, and you fit it to the preference data the same way you would have fit the reward model itself. And that's where you like completely bypass like the RL step, which is the second phase of the optimization, and you're fitting the policy directly on the preference data. So you want your log probabilities to express how likely a user is to like a certain answer.
So less compute intensive. So one from a cost and access to GPUs
Yes.
even, but also the ability to apply these to make AI systems safer is another benefit as we talk
Absolutely.
about guardrailing and, okay, I don't want the model to shoot out certain things or
Yes.
say certain things. So how can DPO be used in that process as well?
Yeah. So DPO, just like any other method, will do exactly what your data tells it to do. And if your data tells it to do, hey, I do not want to answer a certain class of questions, what you do is you collect those questions and you label, I'm sorry, I cannot help with this question, as like the preferred response. And once you run your algorithm on top of that kind of data, you can expect very reasonably that it will avoid answering a certain class of questions. This kind of flexibility is obviously nice for users and companies to decide what kind of models they want to vend and what kind of applications they want to target. And yeah, I think this is where another aspect where I believe accessibility with DPO is like very important. I think a lot of the progress in machine learning is because of the data we're training on. And it's not easy to like study the kind of data quality we have. And do you want data to like not respond to certain kind of questions? If I train on this kind of data, does the model become more helpful? And if you have very expensive procedures to like even like just get to like how does the data affect the model, it becomes harder to study the data itself. So I think one really promising or like interesting aspect of a DPO is that it helps you study how good your data is in a much cheaper way and like may iterate over the data mixtures itself.
You also say that you're able to diagnose instabilities in models and training for RLHF
Yes.
using this. Can you talk a little bit about
Absolutely.
how that happens?
Yeah, so as I said, reinforcement learning can often lead to like very unstable algorithms. So now what does that look like? Is that your policies will often, like the language models that you're optimizing, they're typically optimizing for some kind of a score function there. And then you're trying to improve the score, but something can go wrong and it's very uninterpretable. The scores might go really high, but the language model itself is actually producing gibberish, which is a strange outcome to see, right? Yeah. And there's a lot of moving pieces. There are things called value functions. There are typically things called replay buffers and things which are like hard to like diagnose why it is going wrong because they're not as easily interpretable as quantities. And when there's moving pieces, it's just hard to like, let me fix this and maybe it'll work better. And I think one of the bigger problems that is hard to tune is the fact that during the training itself, you have to sample the language model for many, many answers. Now, people who use this know that sampling is very slow, and your data quality that you sample during the optimization itself can heavily affect like the final outcome as well. So it's slow, it's computationally expensive, and it's hard to like debug. With direct preference optimization, there's actually no sampling during the optimization itself. You take the data set that you already have, and you optimize for the preferred answers. And this is very interpretable in the sense because you measure something called the log likelihoods, which tells you how likely the answer is under the model. You measure those quantities and kind of gives you an indication whether you're making the right progress or not. And that's really it. It's not very different from how these models are pre-trained in some ways. And these log likelihoods are quantities that practitioners are a lot more familiar with. So it makes like diagnosing instabilities a little easier as well.
To that point, maybe let's segue, because great way to go into the experiments that you guys did, because you did use real data sets that
Absolutely.
are out there. Talk a little bit about, I know you did some sentiment generation, summarization, this
The
escaping me.
chat, yeah.
Yes.
Probably
yeah,
the most
the
exciting one.
dialogue. Yes, the dialogue.
We first started, like, with any research paper, you first have to establish, wait, does this algorithm even make sense? And that's what our sentiment experiment was, is we wanted to, like, have simple setting, like, we know what the, like, oh, this is a good movie review, this is, like, very positive, and this is a bad movie review. So that's kind of the task we were looking at. And we wanted to generate really positive movie reviews. It's a very simple setting. We can, like, nicely study it, and with small language models as well. So we started off with that task, and we found very surprisingly that DPO is actually really good at that. In compared to, like, other algorithms, it was providing, like, basically the best performance. So that really motivated us to, like, move to some more real settings you might actually use with the language models. So the first task is summarization. So you take, a long document or something of that form, and you want to provide a nice summary to it. And it's sort of it has some conflicting requirements, right? Like, you want to represent the document that you're summarizing as well as possible, but you don't want to be too long. So you want to provide a concise summary, but you want to recover all the right elements in the text. And that's really the key and there's a lot of ways to do it, obviously. So when you hand design metrics for things like these, like, maybe I should try to maximize all the key concepts or things like that, it actually is very hard to, like, come up with nice metrics. So something that was very successful actually is directly optimizing for preferences that humans might like. So you give them two summaries and ask them, hey, which one do you like more? Which one is more representative? And so there are some data sets online which already have these, like, curated preferences where users already tell which summary is better than which one. And we took those data sets and we said, all right, let's run some, like, real experiments here with real language models. We tried something on the 6 billion parameter scale at the time, which is pretty reasonable sized at the point. And we found that, like, and this is, like, it's very fun to see when these things happen, because, there's all these cool methods that are much more computationally expensive, which we could probably not even run properly if we wanted to. And we tried this very simple method, and it's, like, giving, like, better performance than those methods. And it's much more simpler to implement. We understand what is going on. It basically worked in the first try. So we got pretty nice results for summarization, and, like, it's very competitive with, like, much more computationally expensive things. And then we decided, okay, like, summarization is awesome. So what's the real application that typically people use RLHF for? And that's, like, chat. People want to talk to these language models, so we need to target this application. So Anthropic released this really nice data set called the Helpful Harmlessness data set. And it's a very nice chat-oriented data set that we worked with. And we found that, like, these language models, we trained slightly smaller language models. Eventually, like, we trained, like, 7B models, we trained 13B models. And you could start getting, like, reasonable performance already. You could talk to these models, they could answer simple queries. And yeah, like, we had enough to write a paper already. So, like,
like, wrap it up.
Absolutely. I think what happened after we released the paper is something that's been, like, something that I've been very positively surprised by.
Yeah.
The community has, like, taken it up a lot, and, like, they've liked it. So that's something that's been, like, really exciting to see.
I thought something that was interesting in your guys' paper was you actually used AI to label as well, right? You mentioned what a human would prefer. Not everyone has the ability to hire a bunch of humans to label stuff. So that also is an interesting way for these things to scale kind of on both sides.
Absolutely, yes.
So talk a little bit about that.
Absolutely. Yeah, this is a very interesting emerging topic, and we, like, sort of only touch upon it. Our main goal here was to evaluate whether a model is good or not. And, going out to humans and doing, like, large surveys on hundreds of responses can be pretty expensive. So we kind of plugged in, like, GPT-4 in our case as saying, like, oh, what would a human like? And, like, that's a proxy for what, we use GPT-4 as a proxy for humans there. But there's a very nice emerging field called, like, AI feedback, which essentially wants to avoid, the problem of humans labeling data. And there's other issues. It's not just about scale. Human feedback can actually be very noisy. It can be, like, hard to, like, train humans to give calibrated feedback. And there's limitations to what you can get out of a model just based on human feedback. a lot of people are excited about the idea that like, what if we can get really strong models to give feedback to the language model itself and kind of construct like this self-improving system where a language model generates an answer, then the language model itself scores the answer saying, oh, this is maybe like not the right way to answer this question, try doing something along these lines. And you can iterate like over and over again to get like increasingly improving language models. But the nice thing there is that no humans, or you're not critically bottlenecked by human feedback in the process. And this whole process is typically called like AI feedback. And it's an emerging topic. People are still studying it. And we'll see how it goes. But like this is one thing that could like allow us to make models even better at a cheaper cost.
Really curated and
Yes.
specific to certain things.
Yes.
And very high quality and fun to interact with.
Yes.
And so as you think about the user experience, just gets better
Yes.
and better.
Yeah, and then that's an important point because like a lot of the data that you collect from human laborers can often be very noisy, and it's not necessarily the highest quality, but potentially if AI models give the same feedback, you can have more control over what kind of feedback you get, and it can be less noisy. So you ultimately get better models potentially, and then users have like better experience and maybe even more controllable experience. They can tailor the experience to themselves. Yeah, so that's like an.
You're talking about like even a consumer could have uber personalized.
Oh yeah.
Yeah.
That's like an exciting emerging area that I'm like very interested in. Yeah, like I mean, right now we're training like RLHF models for everyone, but like everybody has different needs, everybody has different backgrounds, everybody comes with different educational experiences, cultural experiences, and you want to like have answers which are personalized to your experiences and the style that you interact in. And I believe we can build those models. Like, I mean, it's a difficult technical problem, like serving at scale to billions of users, models which are like hyper personalized to them. But it's very exciting to think about how we can create such a future.
Let's chat a little bit about what else you're working on now. The paper's been out and published for a little bit. What's taken up your time?
Yeah, so we talked a bit about personalizing language models. I think that's something that I'm working on and I'm super excited about is like how can we build language models which are tuned to different personas, different educational backgrounds, and different things that people might expect a language model to do. I find this very exciting, and hopefully like we can like come up with something which you can feel the difference interacting with, and that's sort of the broad goal. Another direction that I find really exciting personally is like we want these language models, these are like good at generating text. We want them to reason better as well. And once we can like build these reasoning machines, there's so much we can do which is better. They're already really good at generating code, but imagine if they can like write really large code bases by themselves. Imagine if they can like help us construct scientific experiments for us. And there's a whole future to be built where these are like nice companions, not just like in for us in like science as well. And if we can build such like code reasoning machines, that's something I'd love to do. And I'm very excited about using reinforcement learning in these contexts. And yeah, hopefully we can see where it goes. Yeah.
Well, thanks so much for the time. It was awesome to get to chat through this.
Absolutely. Thank you for inviting me to the series.